During these videos of Chapter 1, we have been looking at the atmosphere itself, what it looks like, and how we can describe the atmosphere using things like density, pressure, and temperature. The last description of the atmosphere we're going to talk about, in other words, the last layer of the atmosphere that we need to talk about, is the ionosphere. Now, the ionosphere is this region of the atmosphere that stretches from the middle of the mesosphere up through the thermosphere. What makes the ionosphere so special and so different from the other layers of the atmosphere? It's because the ionosphere is made of ions. Now, what's happening here is gases are heated up so much that the electrons that are orbiting those atoms get excited and separate themselves from the atoms. But there's so much energy that they're not reattracted to each other. They stay separated. This is actually it's a semi-permanent state. This doesn't happen all 24 hours, as we'll see in the next slide. But these electrons are stripped off of atoms, and they generally stay that way in a semi-permanent state. This is actually what we call a plasma. Now, you've learned about three basic states of matter: solid, liquid, gas. It turns out that plasma is a fourth state of matter that we don't often talk about, except for in specific scientific venues, such as this class and this lecture right here. So here in the mesosphere, the atoms and molecules in the atmosphere are excited so much from direct sunlight that you end up with a plasma, a sea of ions and free electrons in this region right here. That is our ionosphere. Why do we care about it? Well, you can have disturbances in this ionosphere due to things such as solar activity. If the sun interacts with our atmosphere in certain ways, then it can cause disturbances in the ionosphere. Also, you can have changes in the Earth's magnetic field, which will cause disturbances in the ionosphere. This is a special field of meteorology called space weather. Happens to be the field of meteorology that I studied for my doctorate degree. Anyway, the point is that when you have these disturbances in the ionosphere, whether from the sun or the Earth's magnetic field, it can actually affect our weather here in the troposphere, and it can also affect our communications. So, yes, we definitely need to worry about the ionosphere. To be perfectly honest, throughout the course, we're not going to talk about the ionosphere much at all. Maybe occasionally, just in passing. But this is really what you're going to see about the ionosphere. But it's important to understand that the ionosphere can affect the weather here in the troposphere. That was actually my dissertation for my doctoral degree, was looking at how these ionospheric events affected weather lower down in the atmosphere. All right, now looking at the ionosphere, there are three basic regions: the D region, the E region, and the F region. The D region is the lowest region and the lowest layer of the ionosphere. This area, during the day, sunlight excites the atoms, the electrons strip themselves off of the atoms, and you end up with a plasma throughout the entire day. But at night, that energy is no longer there. And so electrons will lose their energy and find themselves attracted and recombine with the ions. And so you end up with just your regular, ordinary atoms and molecules that you started with before. Now, this happens completely, meaning during the day you have an ionosphere. At night, you get complete recombination. The ionosphere completely disappears. This is called the D region, the region where the ionosphere completely disappears at night. The E region is just above it. Because it is a little bit higher, it's exposed to sunlight a little bit more, which means that they get even more excited. And at night, the electrons still lose a lot of their energy, and you get some electrons that recombine. but there are some that have so much energy that they last through the night. So the ionosphere only partially disappears at night. This is called the E region. The F region is the third region. It's the topmost, the one most exposed to sunlight. In this case, electrons and ions are just way too excited and will not recombine at night. Okay, got it? The three layers of the ionosphere. The D region, where the ionosphere completely disappears at night. The E region, where the ionosphere partially disappears at night. And the F region, where the ionosphere never disappears. All right, so you may be looking at this video and saying, well, what's with all the wavy lines in there? Let me explain that. It's actually really cool. You remember here how I said that the ionosphere can affect communications? This is one way that it can affect communications. When the ionosphere is especially strong, it interacts with radio waves. And by doing so, it distorts the radio waves until they just break down and disappear. So during the daytime, if you transmit a radio wave, we'll say AM radio. There's a reason I chose AM radio, even though we don't use it as much anymore today. If you send an AM radio wave, it will interact with the ionosphere and disappear relatively quickly. During days where the ionosphere is especially active, those waves will disappear even faster. And so communications can get disrupted quite readily. But at night, when the atmosphere completely disappears from the D region and partially disappears from the E region, these waves can actually propagate a very long way. In fact, while I was living in Florida, there was once or twice where we actually turned on the radio and we heard an AM radio wave from Los Angeles, all the way from Los Angeles to Florida, opposite ends of the country, and we could hear radio waves. It was really impressive. Just to show how much the ionosphere does interact with what we do. FM radio waves cannot travel that far for a number of reasons, but AM radio waves, they can. But the ionosphere, when it is present and strong, can affect with those communications. Okay, that wraps up our discussion of the layers of the atmosphere, and it finishes up as well our lecture series from chapter 1 of our textbook. What have we talked about? We talked about the differences between weather and climate. We've talked about where the atmosphere came from. What's it made of? What are the most abundant compounds or molecules in our atmosphere today? We looked at density. We looked at buoyancy and how they play a role into our atmosphere, as well as pressure. And we saw that density and pressure both drop off very quickly close to the surface and then drop off more slowly with higher altitude. We looked at the four main layers of the atmosphere: the troposphere, the stratosphere, the mesosphere, and the thermosphere. All of these are determined by what's happening with the temperature. With the troposphere, the temperature drops as you go higher. With the stratosphere, that reverses. You get an inversion layer, and the temperature actually rises with altitude. Then mesosphere, it reverses again. Temperature drops with rising altitude. And then in the thermosphere, you have another inversion layer, and the temperatures increase with altitude up in the thermosphere. And then we wrapped it all up by talking about the ionosphere. At this point, you are ready to dive into the Chapter 1 homework. If you have any questions, please feel to reach out to me. Otherwise, good luck with the homework, and we will see you in Chapter 2.